Okay, welcome everybody to today's class. Today is a physics class, really. Years and years ago, when YouTube wasn't a brainwashing organisation, we were allowed to share information with our friends, and that was why YouTube was fantastic. It's sad that it's not anymore, but I learned a lot of information back in those early days by following different people's channels, and I really liked science channels, and so I would build what they showed me on their videos, and I would learn a lot. I learned a lot about resistors, transistors, circuits and that kind of thing, although I'm certainly not an electrical engineer, obviously. Now, building a nuclear fuser at home is much easier than you might think. You only really need two things. You need very high voltage at the right power, with enough current, and that's what this thing is. And you need a vacuum chamber, and that's what this thing is. It looks like this, So you'll need to build two things. You'll need to build a high voltage circuit, and I'll show you mine in a moment, and you will all laugh. And you need to build a vacuum chamber. Because to make a nuclear fuser, to get nuclear fusion to take place, and I must admit that it won't take place unless you really get a very strong vacuum pump, and I don't have that. So I must admit that this nuclear fuser is a demo fuser. To make sure you actually produce nuclear fusion, you might need a vacuum pump better than mine. But this experiment, all you need is a vacuum chamber, and I found out how to build this from another YouTube channel. It was from a guy called Robert Murray Smith. He's still on YouTube, he's a chemist, but he showed me how to build this, and it was very easy. And secondly, you need the high voltage. Now, before I show you my monstrosity of a high voltage circuit, I want to talk a little bit about this. Now, it looks complicated, right? But if you've got any electrical engineering experience, if you've ever put together a circuit, I think you'll look at that and think, that looks surprisingly easy. It's not a hard circuit. And it's called a ZVS circuit or a Mazzilli circuit. I believe this is the circuit that most fuser builders use. And it wasn't a hard one to make. So what have we got in this circuit? We've got some resistors, 470 ohm resistors here. We've got some 10k resistors here. We've got two Zener diodes, 12 volt Zener diodes here, and they sometimes break, so be aware that that's one of the weak parts of the circuit. And we've got two MOSFET transistors here. They're called MOSFETs, and the ones that work are IRFP250. You need two of those, IRFP250 MOSFETs. That's a type of transistor, if memory serves, It's a type of transistor. And they look like this on the circuit diagram. This is a simple inductor, 200 microhenry inductor. And you have some fast switching diodes down here, and they're high voltage diodes. They're 400 volts fast switching diodes. And this part of the circuit, by the way, here's a juicy capacitor that can hold a lot of the electrical energy. So we've got a capacitor there. And this part of the circuit is called a flyback transformer. You can buy flyback transformers online, but I didn't do that. I actually ripped my flyback transformer, and you'll be able to see this. I ripped my flyback transformer out of an old monitor. Years ago, when YouTube was a nice place, I spent quite a lot of time ripping transformers out of monitors and then using them in different experiments, because flyback transformers, the transformers in these monitors, have lots of winds on the coil, and that means you can get the voltages up to really high levels, and that's what we want, right? I've always really enjoyed playing with high voltage. So this part is a flyback transformer, and I took mine out of a monitor. And the turns on this flyback transformer, let's show you the monstrosity. Let's see what I built. Now, you'll probably be amazed that this actually works. Look at the crocodile clips going everywhere, and you can actually see some of what I've just described on this. You can see the Zener diodes at the top there. They're next to those resistors, and you can see the high voltage diodes there. And they're the two MOSFETs. That's one MOSFET, that's the other MOSFET. And you can see it all goes to the flyback transformer, which you can see I blatantly ripped out of a monitor. But amazingly, it still works somehow. And this is what I've always used as my power supply. It's got wires everywhere. If you are making one of these, I suggest you make it to a much better quality than this. The main reason why I've got these crocodile clips going everywhere is because it's very easy to remove and replace a component when it overheats or stops working, which does happen quite often when you're dealing with these high voltage circuits. And you simply attach three 12-volt batteries. I've actually got mine sitting around here somewhere. Look, there's one of them. You just attach three 12-volt batteries, yeah, like that, to that. But be aware that this circuit is deadly. Yeah, you can see the capacitor, by the way, at the back, and you can see very careful labelling going on there with minus and plus. But you just plug this into three 12-volt batteries. That's a lot, and you will get a deadly amount of high voltage coming out of the flyback transformer. I'll put that down now. Okay, and of course I'm going to show you all of this in a second. I'm going to show you the nuclear fuser in operation, obviously, and I want to talk about some of the other experiments I've done with the nuclear fuser. But you can see that's the circuit, right? And this is the vacuum chamber. So you do need a vacuum pump, and the stronger the vacuum pump, the more likely you will get nuclear fusion. You can test the nuclear fusion if you buy a Geiger counter, and you put the Geiger counter near the vacuum chamber, and you should pick up the extra radiation, yeah, that's produced, because it produces neutrons and alpha particles as the atoms fuse together. So, oh, and by the way, you will need to put deuterium gas into the vacuum chamber. That's hydrogen gas, but it's an isotope of hydrogen, because deuterium is the easiest to fuse together to make helium, yeah. So that goes on in the vacuum chamber. And what actually happens is we're going to put, and you can't see this here because mine broke long ago, but I could make another one. They're very easy to make. But I actually had a, and you'll see this in a second on the videos. Perhaps I'll put the videos here so you can watch them right now. But you have this electrode in the middle, and this is at very high voltage, and it's a negative electrode. You've got everything else, this bottom part and this top part, as a positive electrode. And what happens is, as you suck all the air out, the ions, the charged gases, yeah, which are being pulled out, the ions and the electrons get a longer path to go. It's called a mean free path, before they knock into another atom or electron. And this because all of it's getting to be really low pressure. We've got to get low pressure here for this to work. And as the pressure gets lower and lower, the ions and atoms speed up because they're not hitting, they're not slowing down and hitting other atoms and ions. And they're attracted right into the middle here. So the high voltage holds the positive ions inside that cage, and it holds them so tightly, they're at such high energies that they hit and they start fusing together. So the nuclear fusion goes on right in the middle there, and you can hopefully see that on the videos I'm putting up right now. Now, it's not actually just nuclear fusion that this is a very interesting setup for. Especially this high voltage circuit, you can use it for a lot of other experiments, and you can use this vacuum chamber for a lot of other experiments. So years ago, I became very interested in a guy called Christian Birkeland. He's actually a Norwegian scientist, and I believe he's on the Norwegian money, on the krona. So he's a famous scientist. But he was actually famous because he was the first one to point out that the aurora in the sky, in the northern hemisphere at night, that aurora borealis that you can see, he was the first one to state that that is an effect, an electrical effect, from the sun's solar wind. He recognised that highly energetic charged particles were coming down to the Earth and being confined in an aurora by the Earth's magnetic field. And when he said this, and did loads of experiments with vacuum chambers and high voltage to demonstrate that this was the case, he was laughed at. Yeah, everybody said, what a load of rubbish. There was an English mathematician, Sidney Chapman, that in particular attacked him and said the idea that charged particles could go from the sun to the earth is ridiculous over such a great distance. It's bizarre. And of course, Sydney was wrong and Christian was absolutely right. He was the first person to show that the aurora is an electrical effect. So I got really interested in his old experiments because he used to put Torellas, he called them, which were just metal globes in vacuum chambers, and then he'd play with the magnetic fields and see if he could recreate the kind of things we see up in the sky, up in the night sky. And I think he did a wonderful job. He experimented firstly in trying to produce Saturn's rings, simply with electricity and high voltage and low pressure, so a vacuum chamber. And he managed it. He showed that Saturn's rings, well, he as far as he was concerned, rings, planetary rings, are an electrical effect. And I hope you can see me doing exactly this right now. I'll put the videos up where I was trying to repeat or do similar things to Christian's experiments from 120 years ago or something like that, because it fascinated me. So you should be able to see the experiment where I managed to show some planetary rings as well as some auroras. And not only did Christian look at planetary rings and auroras, he also looked at what happens when a meteor goes through a low pressure environment, which is what's happening because space is extremely low pressure. There isn't much oxygen or air or gas or anything up in space, so it's at low pressure. So he took some carbon, some graphite, and he made it fly across the vacuum chamber and watched how it looked just like a meteorite. And I've done something similar with a stick of graphite. I found this great fun, by the way, and I thought it was beautiful, the effects. The video doesn't always do it justice. When you're looking at some of these wonderful plasma displays that you get in the vacuum chamber, they truly are amazing. And so you should be able to see now where I've got a stick of graphite and it's spinning around in the vacuum chamber. And the wonderful kind of spark, the streak, it really is something gorgeous. And it looks just like a meteorite does when it shoots across the sky and you get that shooting star effect. And so it's another lovely thing you can do once you've got your vacuum chamber and, of course, your ZVS. And hopefully yours will look much better than this. If you look at other builds of this, and by the way, you can find out how to build this on instructables.com. They have an excellent schematic. Don't try it if you don't feel comfortable with playing around with deadly circuits, but do make sure you've got a flyback transformer. You can see I've ripped that out. Look, you can see it very often arcs across. It's not a great high voltage. This probably is a little bit more deadly than the average ZVS. And do try and make sure you get strong connections, because otherwise you'll get problems. But you might prefer to do things with quite loose connections, just so you can replace your MOSFETs when they blow up or your xenodiodes when they overheat. But I hope that this has inspired you to go and do some experiments yourself. Because that's what YouTube always meant for me back in the old days when YouTube was a good organisation. It was a wonderful place to go for information, and information was shared freely among friends. And I don't remember anything about censorship or people getting their videos taken down. I'm sure it went on, but I don't think it went on with ordinary videos like this. I think it just went on with the videos that do need to be taken down. But nowadays, I think you can't say anything on YouTube. You can't possibly say anything that would be, not allowed in the media, because YouTube is the media nowadays. So it's a really sad situation that we've come to with YouTube. And if you want any of my English lessons, please go to my website, skype-lessons.com. I won't be making any more educational English videos for YouTube because I hate them that much. And so you'll have to go to Odyssey to find these English lessons. I will carry on putting science videos up on YouTube because that's where YouTube started for me. I actually had a science channel before I had an English channel on YouTube, and I made a lot of friends on YouTube, and I learned a lot on YouTube years ago. Nowadays I don't learn anything. I can only see propaganda on other channels, and if it's not propaganda it gets taken down. I don't like YouTube anymore, and I'd really like it if you could come along to my website or to Odyssey And by the way, if anyone would like to buy English books, I still advertise these books because I'm still for sale. They're still selling wonderfully. And I want to thank everybody who's bought a copy because I never expected that they'd sell so well. So thanks, guys. I do appreciate you putting your hands in your pockets and buying PDF versions or physical versions. It does really help, and it certainly makes me want to carry on making English videos, for example. But please go to my website, skype-lessons.com, and I promise I will carry on making lessons. I actually enjoy making lessons, and I think that in future spreading video lessons is a good thing. It's a wonderful thing. It helps us all learn all sorts of things, you know, I want you to carry on learning with these video lessons. They're great, but sadly, the big platforms now like YouTube, they've become the property of the World Health oligarchs. They're not places where you should be hanging around anymore. So come and join us. Don't focus on the negative, focus on the positive. Come and join us. Come to my website. Come to Odyssey if you want to follow me there. And please, if anybody wants to try to make the ZVS a wonderful circuit, please let me know. And please be careful. Don't touch the output. It's supposed to be deadly. I'm not sure if that's the case or not. I imagine with one 12-volt battery it probably isn't, but don't take my word for it. Yeah, don't touch the output. Seriously, it's a deadly device, but do have a go at making it. It's great fun. Okay, thanks everybody for watching. I hope this video has inspired you to go out and do some science, and I hope to see you all soon at on my website for new English classes. Please come, you're all invited. Thanks.